Okay, so this is our result. We've got our ATR network, our SLU7 network, and we've got 7 overlaps. So what do we do with this? Just looking at this, uh, we're seeing that there's RPA1, RPA2, and check 1, and this could already be the basis of forming a hypothesis that splicing does affect somehow the DNA replication. So maybe if you are defective in splicing, you are not able to produce the proteins that are important for DNA replication or things like that. But that's not really the point here. It's just what do we do next? The first question, and this is the last thing we're going to ask today, is this actually significant? And there's a relatively quick way of figuring this out, and this is also quite intuitive. So we have 17,000 genes in the whole set. If we would form a random collection of 20 genes on one side and of 53 genes on the other side, how likely is it that we would get 7 overlaps? And there's a simple, we could run this test simply by doing the same thing again and again. There would be some sort of bootstrap type of statistics, but there's a simple test that is called a hypergeometric test, which does basically the same thing. It's just say what is the chance of getting 7 overlaps if you take a random set of 20 genes and a random set of 53 genes from a total of 17,000 genes. And again, this is a SciPy-stats function. You can import it, and you have to supply it with the total gene number, and then your ATR network and your SLU network number, and then you can easily get the p-value using this hypergeom.sf method and supplying the parameters into this, and it'll give us the p-value. So we see that our p-value is very, very significant. And that's kind of intuitively, if you just do out of the 17,000 genes randomly 20 genes and 53 genes, the chance to have 7 overlaps is very, very slim. Plus, also, there's some biological significance because we have 3 genes of the same pathway of sort of around DNA replication and checkpoint. So that I think is quite a strong hint that there's something going on. Um, there are then next steps to explore this further. So, for example, a gene set enrichment analysis, and this is something we'll do in the final assignment. But these are things I want, as this would be an example where I would want you to go find the package and read the documentation and learn it by yourself rather than us giving you the code already from the beginning. But to conclude, what we have discovered here today is we have basically now done a real end-to-end analysis. We've done quite a lot of work on this StatMap data set. We found a nice hit. We did some validations. Now we have a final list of genes. And I think, as you said, helped me already speculating, there's immediately a hypothesis coming out of this. So this would then be leading to new experiments, to new insights, and that's exactly what a good bioinformatic data mining workflow should be. You go in very unbiased, you just have a look at the data, there's a pattern coming out, and that pattern will give you a new hypothesis. But for us, the main point is we've learned a lot of techniques and we've seen how some also model analysis looks like, and you will apply this now to your own project in the final assignment. And the functions that you will have to write and the type of analysis that you will have to do will be quite similar. So you have a nice structured template here that you can follow already. With this, we will conclude the lectures. So you can go and have a look at all these notebooks. There's a lot of practice again, and mainly also go through and read this code. Reading code is really, really hard and really, really boring as well, but it's a really good practice. If you're able to go through and find exactly what all these functions mean, and you follow the flow of the variables and the flow of the data, this is a extremely good practice to understand and to learn about coding. So I would heavily encourage you to go through this step by step, do it yourself, play around, break it, change, look what happens when you change things. to really understand each of these individual steps. And then you have to apply it yourself. You have to write it from scratch new for your own analysis, which will be very productive for you to learn to become budding bioinformaticians. So with this, I will leave you in terms of lectures with this course. I will prepare some more specialized topics later in the course on image analysis, and on literature analysis, but this is not obligatory. So I've already given you quite a lot of stuff to play around with. But generally, I think you're really at the beginning now. You have learned a lot of fundamental skills, but so don't stop now. The best way now next is to see how can I apply what I've learned to my own projects. And that's really the most critical next point. And as you will build your own projects, start with some small steps and build them up. If you look at your own data set, you will find there will be new challenges, and you will need to either build new code yourself, so you will need to learn new techniques, or you will import new packages that will do things. So you will really continue learning altogether. And I think this is one of the most beautiful things about coding, is that you never stop learning. It's similar to practicing an instrument. There's always ways to get better, learning a new score, learning a new technique, practicing this technique. So it's something, if you catch on with this, it's something that will really stay with you, and you can use it and apply it in many, many different ways. In terms of bioinformatics, I think the next three big topics that you can think about is go deeper into NGS analysis if you're dealing with a lot of sequencing data. Go into image analysis. This is where Python really shines, and where Python shines most, obviously, is in the machine learning and AI world. So this is very timely. AI is really revolutionizing everything. So being able to write Python code gives you an immediate access to a lot of very powerful tools in the AI world. So I would encourage you to go into the data camp lectures as well and learn how to apply agentic AI and write your own AI code. This is something you can really sort of do some very cool stuff with not that much Python. So you don't need to be a really Python software engineer to become productive with these things. So another thing to consider is to move on from Colab, which was very helpful for this course. But I will provide you in the next couple of weeks with the resources to build your own development environment on your own machine and start using an integrated development environment like VS Code, and learn about packaging and start using the terminal a little bit, and then even start learning Git. So these are kind of the development skills that are make you much more productive as a coder, and that they are very useful to learn. So I'll try and will communicate that with you over the next few weeks in the rest of the course. But with this, I will leave you. You're ready now. Well, you need to practice, obviously. I've given you a lot of material. I hope it was not too much. I know we went through things very fast, but I've given you a lot of practice material as well. You have to do things by yourself. Keep coding, keep learning, and keep building. And enjoy.